Hey, welcome to The Explainer. So get this, in the world of cybersecurity, one of Russia's most infamous hacking groups goes by at least 4 different names. Today, we're going to find out why. And we're going to decode the secret language of the people who hunt them.
And just so you know, all the info in this explainer comes straight from the source material, threat hunting terminology.
That is a fantastic question, right? And we are going to get to the bottom of it. But to really understand the names, we first have to understand the battlefield. So let's start with the absolute basics. Okay, let's dive right in with the core concepts. Before you can even think about hunting a threat, you've got to know what you're looking for and who you might be up against. It all starts with a threat. Now, here's the thing. A threat isn't an attack that's already happened. The key word here is potential. Think of it like a known vulnerability on a server. It's the potential for something bad to happen. And what's that threat aimed at? An asset. And this is a super broad term for basically anything that has value. It could be your personal laptop, or it could be a massive company's entire server infrastructure. Next up, you have the threat actor. This is the person, or more often the group, that tries to turn that potential danger into a real one. They're the ones actively trying to exploit a vulnerability. So how do they actually get in? That's where the threat vector comes into play. You can think of it as the how. It's their path to gain access. A super convincing phishing email or an open, unsecured port on a firewall? Both classic threat vectors. All right, now that we've got the basics down, let's level up. We're not just talking about any old threat actors. We're talking about the most sophisticated players in this high-stakes digital game. These are the big leagues, the elite groups known as Advanced Persistent Threats, or APTs for short. A lot of times, they're backed by a nation-state, which means they have tons of resources. And their name really tells you everything. They're advanced in their skills, and persistent, meaning they can stay hidden inside a network for a really, really long time. So what makes these APTs so incredibly dangerous? Well, they're experts at finding brand new, totally unknown vulnerabilities. We call these zero-day exploits. Why zero-day? Because the moment they're used, the good guys have had, you guessed it, 0 days to come up with a defense. Okay, so this is where things get really interesting and honestly a little bit confusing. It's how the security industry tries to keep track of all these different APT groups. It's a bit of a mess. And boom, this table just lays it all out. The reason for the confusion is pretty simple. There's no industry-wide rule for naming these groups, so every security company just makes up its own system. Let's take this one Russian group, for example. The security firm Mandiant, they call them APT-29. But then you have CrowdStrike, and they go with the name Cozy Bear. Over at Microsoft, they call them Midnight Blizzard. And then there's the nonprofit MITRE. They keep it simple with just an ID, G0016. It's wild, right? 4 totally different names for the exact same group of hackers. So if the names are just a big mess, how on earth do we actually track what these groups are doing? Well, instead of tracking the name, we track their behavior. And for that, there's a universal framework. And that framework is known as TTPs. It stands for Tactics, Techniques, and Procedures. This is the language everyone in the security world uses to talk about what an attacker is actually doing. Here's how it breaks down. First, you have tactics. Think of this as the high-level goal, the what, something like get inside the network. Then you have techniques. This is the how. How did they achieve that tactic? Maybe they used a phishing email. And finally, you get down to the procedures. This is the super granular, step-by-step playbook of exactly what they did. Okay, so if these attackers are using specific TTPs, they've got to be leaving some clues behind, right? So how do the good guys, the threat hunters, actually find these digital fingerprints? They look for these little digital breadcrumbs called indicators of compromise, or IOCs for short. Now, an IOC is any piece of evidence that hints that something bad might have happened on a system. It's not a smoking gun, but it's a huge red flag that says, hey, you need to look at this right now. And these IOCs can be all sorts of things, right? A weird IP address, a sketchy domain name, a file name that's known to be malware, even specific bits of text inside a file. But one of the most reliable and powerful IOCs is something called a file hash. So what's a hash? Just think of it as a file's unique digital fingerprint. A special algorithm looks at all the data in a file and spits out this unique string of text. And it's so sensitive that if you change just one single bit in that file, just one, you get a completely different hash. It's incredibly precise. But what happens if two different files somehow end up with the exact same hash? Well, that's called a collision. And if a bad guy can intentionally create collisions, it means that hashing algorithm is basically broken. You can't trust it anymore to prove a file is what it says it is. And that's exactly what happened with an older algorithm called MD5. It's been proven that you can create collisions with it, so nobody considers it secure anymore. That's why today, the gold standard you'll see in pretty much every professional report is SHA-256. It's modern, it's secure, it's what the pros use. So there you have it. We've kind of pulled back the curtain on this secret language of threat hunting. From the basic building blocks to the crazy, confusing code names for APTs, and all the way down to the digital fingerprints like hashes that help us track them. Now that you speak the language, what secrets could you uncover?
Hey, if you found this dive into the world of cybersecurity valuable, do us a huge favor and hit that like button and subscribe. Seriously, your support is what lets us keep making more of these explainers. Thanks so much for watching.